Okay, in today's lesson we're going to discuss how to prove triangles congruent. And let's take a look and see what we got here. The first way to prove that triangles are congruent is called the side-side-side postulate. And it states if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. So you can see in triangle GHY and triangle ZYX, we have one pair of congruent sides, we have two pairs of congruent sides, and we also have three pairs of congruent sides. So these two triangles are congruent by side, side, side. Okay, the next way is called the side angle side postulate. And it states if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So the key to this one is knowing that what included means. Okay, included basically means the angle that's between the two sides. So if I look at this diagram here, I have a pair of sides congruent here, I have a pair of sides congruent here, and the angles that are congruent are between the two sides, making them the included angle. So these are congruent by side angle side. Okay, next we have what's called the angle side angle postulate, or ASA. All right, and it states if two angles and the included side of one triangle are congruent to two angles and the included sides of another triangle, then the triangles are congruent. Again, in this case, the side has to be between the two angles that we are dealing with. So if you look at our example here, okay, we have one pair of congruent angles, and we have a second pair of congruent angles, and we have the two congruent sides that are included between the two angles. So these are congruent by angle side angle. Okay, and finally we have the angle angle side theorem, or angle angle side. Now this one is similar to the last one, but in this case you can see the side is not included. It's not between the two angles. So if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So if we look here, we have one pair of congruent angles here, we have one pair of congruent angles here, and the two congruent sides are not between the two angles. So this would be angle angle side congruency. So we're going to try some examples and see if we can identify which theorem or postulate is taking place. So in this first diagram here, we have two triangles. We have these two sides congruent, these two sides congruent, and I'm going to go ahead and I can tick mark these two because of the reflexive property. They share that side. That would give us our third pair of sides. So this one's side, side, side congruency. Try the next one here. Here's a pair of sides. Here's a pair of angles. And there's nothing else I can add to the diagram. So this one is no. All right, they're not congruent because there's not enough information. Okay, next, I have a pair of angles here. All right, I have a pair of sides. And I have these two angles congruent because they're vertical angles. And I know vertical angles are always congruent. So that gives us another pair of angles. So looking at our diagram here, it looks like I have two angles and the side is between the two angles, so this is going to be angle side angle. Okay, let's try another one. Okay, here we have a pair of angles here. And we have a straight line and a 90-degree angle, so this has got to be 90 as well. So there's a second pair of angles. And we also have the reflexive property. Again, they share that side. So that would be a pair of sides for both. And we have two angles and a side. Now this side is not between the two angles, so this is going to be angle, angle side. Come to the next one here. All right, we got two pairs of sides and another pair of sides here. And then we have our vertical angles in the middle. And I know vertical angles are congruent, so that gives me a pair of angles congruent. And you can see that the angles in this case are between the two sides. So this is going to be side angle side congruency. Okay, let's try this one here. Here we have two right angles that are congruent, and we have vertical angles in the middle. And I know vertical angles, like always, are congruent, so that gives me a second pair of angles here. Okay, and there's nothing else I can see that I can add, no tick marks or anything, so angle angle is not enough for congruency, so this one would be no as well. Okay, the last thing we're going to do is put everything together here, and we're going to do a two-column proof. So we have statements and reasons. All right, so first I'm going to develop a plan here. Okay, I have some given information. EF is congruent to FG. DF is congruent to HF or FH. Okay, those are already tick marked, and I'm trying to get these two triangles congruent to each other. So I'm going to treat this like I did before. Okay, I have a pair of sides congruent here, and I have a pair of sides congruent here, and I can add these, okay, because those are vertical angles. Those show up quite a bit. Vertical angles are congruent. So it looks like these two triangles are going to be congruent by side angle side. So I'm going to organize all my thoughts and basically complete this proof, converting all this into a two-column format. So first thing we're going to do is take the given information and write that as statement 1. Okay, the reason is given. Okay, statement 2. We added our vertical angle, so I'm going to label that as statement 2. So angle, let's call it DFE, is congruent to angle HFG. And the reason, vertical angles are congruent. And that led us to proving the triangle's congruent. So I am there. Triangle DFE is congruent to triangle HFG, and that was because of side angle side. All right, that concludes our lesson on triangle triangle congruency.